Good evening, everyone. My name is Augustine.
I'm David Dunlap.
I'm Christian Saldivar.
I'm Gunnar Spradley.
My name is Hosuk John.
This is Uboat. That's the name of our group. The name of our boat is called Navis. We picked this name Navis because today is Spanish Appreciation Day. The goal for this project is to design a cardboard canoe that will be able to withstand the design parameters, which is to be able to float in the UT Tyler Lake and as well be able to make it across the pond and back. We're gonna have 2 paddlers on the boat itself. The goal is to win and to be able to accomplish the engineering design problem. I'm gonna pass this over to Hosek.
Okay, so the total weight for this canoe came out to be 37.2 pounds, and we used 570 linear feet of tape, and the tape's type was 6 Gorilla duct tapes from Home Depot. We also obtained double corrugated cardboard from Home Depot. We used 8 large boxes and 5 small boxes to create this cardboard canoe.
The dimensions of the canoe, we started with making the width 45 inches wide because past people in our group have actually done the project and they have told us that making the boat too thin will actually cause it to not balance as well. So we're taking a different approach, and instead of having 2 people traditionally behind each other rowing, we're gonna have 2 people but next to each other. So one person will have a designated side to row and the other person will have his designated side to row. We also made it 67 inches long with a pike nose at the front so it can cut through water. We decided to make it a little longer, that way we could also be more balanced, be more spacious, we wouldn't have to be tied in to each other. And we also decided to give it a height of 20 inches because we don't want it to be too low where water can potentially get in to the canoe through the sides. So we tried to factor in both of our weights to make sure that water wouldn't go in, and we decided that 20 inches would be more than enough to avoid water from coming in.
Yeah, and when we tape the bottom of the boat, we're very careful to do horizontal as well as vertical lines of tape in order to make kind of a weaving and interlocking system that would be more waterproof than just taping it all one way and having the seams all facing in one direction. And then as well, when we constructed the boat frame, we tried to fold as much cardboard as possible where we could instead of cutting. For example, we made double thick cardboard walls in order to resist the force of the water trying to collapse the boat. And instead of cutting 2 separate pieces of cardboard and putting it together where you could potentially have a leak and have to tape that, instead we took one big piece of cardboard and folded it so that way it wouldn't have any gaps to leak. Even in case the water gets through our tape, it wouldn't go straight into the boat. It would still have to go through a layer of cardboard. And then our wall height, as our teammate said, is going to be very tall in order to prevent the water from coming up. If it goes up more than our calculations, we still got plenty of height in order to give us more buoyancy force and to account for any errors or weakness of the material itself.
To determine buoyancy, we had to throw back to fluid mechanics. The basic equation is the density of water times gravity times the volume of water displaced. We calculated that value to be 1,873 pounds. In our lab report, we decided to put pontoons on the side of it to try to give us a little bit more buoyancy and a little bit more stability. Our average weight of our rowers is about 170 pounds, which is significantly lower than the pounds of force that we calculated in buoyancy. So we decided not to put the pontoons on the side. It also made the construction a little easier as we were having a little trouble trying to attach it to the side. It gave us a lot more room to put our canoe name and our team name on there. And we had plenty of stability as wide as we made our boat. 45 inches is 3 under the maximum, and you know, having 2 people side by side, we're gonna have a lot more stability than front and back from tipping side to side. We also pre-tensioned the outside walls. You know, once you put it in the water wants to collapse everything in. So when we first put everything together, the walls wanted to push outwards. We ended up wrapping a couple layers of tape all the way around the side to pre-tension it and maybe put some force pushing outwards to try to counteract the water pushing inwards.
In conclusion, the goal is to win. We're coming for each and every group, and we'll see you then.